Alrighty, so now that we are familiar with the different terms on here, we are going to connect these different pieces of the equation to algebra tiles. We're going to be using algebra tiles to help us solve equations, combine like terms, do the distributive property, and all that jazz. I didn't leave any with Miss Mahmood and Miss Salim. So you're going to have to follow along with the ones that I've got here, but know that when you get to my room, you guys are going to have access to these. So there's 3 different shapes of algebra tiles. The first ones are these big squares. These big squares represent whenever we have a variable squared. So like if we were to ever see, for example, if you were ever going to see x squared, that would be this big positive square. This side length is x, this side length is x. It's positive because it's blue. If we wanted a negative x squared, though, we just flip that over and it would be on the red side. The red side means it's negative, the blue side means it's positive. We will only get into using these when we're combining like terms if we have variables with exponents to them. The other 2 pieces are much more common. Our variable pieces. You guys might have seen these before last year in 7th grade. This long piece here is a variable x. It's blue, so it's positive. I think on your next few slides, it shows green for positive. Either one is fine. You'll always have some sort of answer key, or they'll put plus or minus signs on this different shapes to show you what they represent. And again, this is long, so it's an x, but it's red, so red makes it a negative x. You're just following along. You don't have to write this down anywhere. And the last ones you're probably pretty familiar with. They look like those little integer chips, those colored counters that you guys would see in 6th grade for like integer operations where you're adding positive and negative numbers. So these are ones. Yellow's a positive 1, red is a negative 1. Those are constants like we just talked about in our equation. These are variables like we just talked about in our equation. These would also be variables, but they just have different degrees of power to them. But again, we're not really going to get into these. What we're going to do now is we're going to think about what these would look like, how we could use these shapes to build out equations for these situations. Again, these constant numbers are going to be our small little tiny pieces. The variable are going to be these long sticks, and the coefficient tells us how many of those long sticks there are. The constants tell us how many of these ones there are. The coefficient tells us how many of the variable pieces there are. So for example, if we were going to build this out, how would I represent 5 using my algebra tiles? Well, 5 is a constant, so I need to use my tiny little ones. So I'm going to count out 5 of them. But now I've got to think, do I want those 5 to be red or do I want them to be yellow? Yeah, we want them to be yellow. Why? Because that 5 is positive, exactly. So this part here represents our, let me see if I can get crazy and write. This here represents our 5. If this doesn't work, you can't laugh. So this is our 5. Ugh. Oh, maybe I can only write on that screen. Let me try to make this smaller. Yep, I can only write on that screen. It's not going to work. That's all right. Ignore my last video. So here's my -5, and then we would have an equal sign here. My next piece is going to be an x piece. And how many do I need? 3 x's. My coefficient tells me how many of those x pieces I need. I need 3 x pieces. 1, 2, 3. And what color would I want them to be? My coefficient is positive, so I want them all to be the positive color, which is blue. So 5 equals 3x. What would a -1 look like? 1's a constant, so it's going to be one of these little pieces here, yeah. So this would be 5 equals 3x minus 1. All we're doing right now is we're just building these equations. We're not worried about solving anything. We're just going to build them. So as I'm going through, I'm going to do a couple of examples. Tell me how you think it would look like if you would build it. And then you're going to do some practice ones on your own where you're drawing in your Nearpod, where you're building them. So let's think about the equation 2x equals 6. Starting off pretty basic. What pieces would I need first? I need x pieces. And how many do I need? 2, because my coefficient is 2. So I'm going to grab 2x pieces. What color? Blue, because blue is positive. So those 2 blue pieces would equal, what would 6 look like? My little integers. And they need to be yellow, right? Because they're positive. So 2x's is equal to 6. Yay. Simple enough, right? Let's try another one. Let's try 2 plus x equals 6. A little bit different. Because now, is this 2 a coefficient anymore? Now it's a constant. How would I build 2 as a constant? Yeah. 2 of these yellow pieces plus x. How many x's do I need? It doesn't say. Just 1 x. There's an invisible 1 out front if it's not written there. We only want 1 of these x pieces now. So now we have 2 plus 1x equals, and now we need 6 on this side. So this is now 2 plus x equals 6. Yay. Alrighty, let's go again. Doesn't have to be pretty, that's okay. It's not going to end up in a pretty number, but we're not solving, so it's fine. Trickier. Negative 3x plus 2 equals 12. So let's start out here. Is that negative 3 a coefficient or a constant? Coefficient means it's with my variable, so what piece should we use? The longs. And what color? It's a negative coefficient, so we want red. We want 3 negative x pieces, and then plus 2. Is there an x with that? No, so we just want these little guys here. So 3x plus 2 equals, now we need 12. 1, 2, 3, 4, 5, 6. Why am I using yellow? Exactly, it's positive. Positives are yellow on these ones. Nice job. Let's try one more, and then I'll have you guys finish up the rest of the Nearpod trying some on your own. (4x minus 1 equals negative 3. How would I build 4x? Think to yourself. What would minus 1 look like? What would negative 3 look like? Those 4x's are going to be my long pieces. My negative 1 is going to be red. Why? Because minus and negative mean the same thing. They mean the same thing. And on this side I need negative 3. Go ahead and try the next 4 slides. Have examples where you're drawing your own algebra tiles that go with the equations. If you want to use light blue for your x's, you can, or the key shows you greens. Either one is fine, just as long as your negatives are red. Good luck with it.